this video, we'll talk about cardiac action potential. So what is an action potential? An action potential can be defined as a fast, sudden, transitory and propagating change of the resting membrane potential. So in our heart, the cardiomyocyte is negatively charged, or it is electronegative at rest with a resting membrane potential of negative 90 millivolts. So now, what do we mean by they are electronegative, or why are they negatively charged at rest is because of the concentrations of ions within them. So here we can see that inside a cardiomyocyte, the concentration of ions such as sodium, calcium and chloride are less compared to outside, while the concentration of potassium ion is much greater inside than outside the cell. So, a cardiac action potential can be described in 5 phases. We'll use this diagram to talk about cardiac action potential. So, what are these phases? Or what happens during these phases are that there are movements of ions to and from the cell, which causes changes in the charges of the cell, which then causes changes to the cell or to the myocyte, such as depolarization or repolarization. So first we have phase 4. This is phase 4. So what happens in the phase 4 is that the myocyte is at rest, that is with a resting membrane potential of negative 90. So now say there is an incoming stimuli or an impulse. So what happens to the myocyte is that the voltage gated sodium channels of the myocyte will open, hence causing an influx of sodium. So now with an influx of sodium ions, what happens is that the electronegativity of the myocyte will become less. The cell will become less negative in charge. Say at a point, the charge will be negative 70. So this value is important because negative 70 is known as the threshold potential of the cell. So what is threshold potential is that the cell has to attain this potential for it to further undergo an action potential. So now the sodium ions will continue to enter the cell, causing less electronegativity in the cell, and around negative 40, L-type calcium channels will open, causing an influx of calcium ions, hence resulting in a reduction of the electronegativity of the myocyte. This happens in phase 0. And now you can say that depolarization of the myocyte has happened. Now we'll talk about phase 1. When the charge of the cell will reach around positive 30, potassium channels will now open, causing an efflux of potassium. So in the beginning we saw that inside a myocyte you have a large concentration of potassium ions. So with the opening of potassium ion channels, there will be an efflux of potassium ions. In this stage, the sodium channels which was previously open will close, but the calcium channels will remain open. But if you see, the efflux of potassium is more dominant and much faster than the influx of calcium, hence causing a reduction in electropositivity of the cell. So in our graph, this segment will represent this one, which can otherwise be called rapid repolarization. Now coming to phase 2. In phase 2, calcium efflux will be equal to the calcium influx. So in this, there won't be any changes in the charges of the cell. Hence this phase can be called a plateau. So the charge of the cell will remain the same for some period of time. And now phase 3. In phase 3, which can otherwise be called as repolarization, what will happen is that the calcium channels will now close and potassium efflux will increase. Hence the cell will return to its resting membrane potential, that is back to negative 90 millivolts. So this is all about cardiac action potential. and its 5 phases.